Hello AI lovers, welcome to AI Sciences. I am Sajjad Mustafa and today we are going to learn feature binarization. Now what is feature binarization? We will learn that in a minute, then we will go towards its importance. We will also learn K-Bins-Discretization or K-Bins-Discretizer, and finally there will be a lot of hands-on practice in Python on some real case scenarios. So let's get started. First of all, what is feature binarization? And by the way, if you're a beginner to AI, artificial intelligence or data science, then AI Sciences is the platform for you. We have a lot of courses for beginners that focuses only on the beginners and a complete roadmap for the data science. So welcome again to AI Sciences. Okay, so now what is feature binarization? We all know that what is feature. If we have some issues with what is feature, please check out our previous videos, and we have a complete course on feature engineering available. You can check out the channel or website. So let's say we have these features: country, age, salary, and purchased. First of all, let's learn what is feature binarization. So according to definition, feature binarization is the process of thresholding numerical features to get Boolean values, right? So let's say this column is a numeric column, right? This age column, right? So we want to threshold it to some level so that we can convert this column to a Boolean column, right? Now what benefit, how can we do it? Let's forget it, we will do it in a while. But why should we do it? Now let's say you're training a model that requires a column in a Boolean format. Let's say age column, it doesn't require ages in a numerical format. It actually requires ages in a Boolean format such that anyone above age, let's say 18, right, it should be called as adult, okay, adult, and anyone below 18 should be called as let's say kid, okay. So adult, and so on. This is also adult, this will be kid, and so on, right? So that's how you can convert your column to a Boolean column. You might be saying that it is not a Boolean column, it is still a character column. So you can refer adult to true and kid to false, and so on, right? So that's how you, and also same goes for the salary. Let's say you want to see if salary is taxable or not. So you apply some threshold. Now here is the threshold. This 18 is a threshold. Let's say you apply 6,000, actually 60,000 as a threshold on salary column. So anyone above 60,000 will be taxable. So this is taxable. This is not taxable. This is also not taxable because it is lesser than 60,000. This is above 60,000. It is also taxable, and so on, right? So that's how you theoretically convert your numeric columns to Boolean columns. Later on we will also see K-Bin-Discretizer, where Boolean value will not be our goal will be something else. So before going to K-Bin-Discretizer, let's first implement feature binarization on Python in our Jupyter notebook. So in the beginning we are just importing two libraries, pandas and binarizer, from sklearn. Don't worry, I'll also implement binarizer in core Python. By the way, so far I hope you have understood the importance of feature binarization. It totally depends on your scenario. If your model requires a binary feature, you have to implement feature binarization on your numeric columns, and this threshold is very important. This has to be very correct. And how can you choose a good threshold? That's totally, that's very subjective. So let's first import our libraries, and here we go. Libraries are imported. Now let's import data, or let's read data. Here I have a data file of a few records. Just like I was showing you in slides. This is the data that we have. So let's play around this data, and first of all let's collect age and salary in separate columns. So all I'm doing is data set where we are reading the data. By the way, how can we read the data? PD, which is pandas, here you can see that. So pd dot read CSV, we have a CSV file, and then we just have to pass the path of CSV file. Since my CSV file just lies in my parent folder, that's why I'm giving it just the name of folder, right? Just the name of file, sorry. Then we are displaying the data by using dot head, and it is displaying by default 5 records. If we pass some value to it, let's say 10, it will display 10 records. Perfect. 9 because it starts from 0, so it is total 10. Okay, now dataset was our variable where we have read the data. So dataset dot iloc, I mean index location, and get all the columns on all the rows on column 1, right? Because if we look here, so this is our column 1, so we need all these values, all these areas. So all the rows on column 1 get its values, and same goes out for the second one. Get row number column number 2, this salary column, and all the row values. So it will get all the salary values in salary column. Let's print it out, and here you can see that original data is this for age is this 44, 17, 30, 38, and so on. Original salary data is here, you can read it out. Now let's move on. We have read the data, we have displayed the data. Let's move on towards feature binarization. So let's say I'm implementing this on dataset age, on the age column, right? So for I in dataset age, it will iterate over all these values, right? And then I'm just using list comprehension. If you're not aware with list comprehension, please check out our complete course on Python, so where this list comprehension is completely explained. Okay, so for I in dataset age, if I is greater than 18, add adult to it, otherwise add kid to it. Let's just run it, and here you can see that. So on number 1 it was 44, which is above 18, it says adult. On 17, which is less than 18, it says kid, and so on. You can see that there are only let's say 1 and 2 values that are less than 18. So here we can see that there are only 1 and 2 values that says kid. And same goes out for the salary. If you can you want to implement feature binarization on salary, you just have to pass a threshold. Here is the threshold, and if it is greater than 60,000, it says taxable. If it is less than 60,000, it says not taxable. So let's run it, and you can see that first is taxable, then not taxable. Here you can see that this is taxable because it is greater than 60,000, and then this is not taxable, this is not taxable, and exactly the same thing. Okay, now if you want to convert it to Boolean features, which is true or false, you can change the values over here, right? But this is an implementation in core Python. Remember one thing: whenever there is implementation available in any library, use that library instead of your own implementation, because that library is being used by hundreds of thousands of people, and it is much more efficient and much more tested. So there is no chance of error in publicly available libraries. So try to use those. So here we have imported Binarizer from sklearn preprocessing module, and what Binarizer will do is, first of all, we will reshape our data, because Binarizer requires a data in this shape, like right in 1D array. So we are in X we have age, reshaped age, and in Y we have reshaped salary. Perfect. Okay, now in Binarizer we have to pass a threshold, just like we have done over here, right? So we are passing 18, and for Binarizer 2, which will be implemented, we will be implementing on salary, it says 60,000, right? And then we are just saying Binarizer 2 dot fit transfer. Actually, this should be Binarizer 1, right? This is for the age. So Binarizer 1 dot fit transform, which is built-in method, and here we will pass our values. And Binarizer 2 dot fit transform, and here we will pass our reshaped data, and let's run it. So here you can see that Wherever there is 1, it says true. Wherever there is 0, it says false. Wherever there is 1, it says okay, age is greater than 18. Wherever there is 0, it says no, age is not greater than 18. And same goes out for the salary. Wherever there is 1, it says salary is greater than 60,000, and wherever there is 0, it says salary is less than 60,000. So that's all about feature binarizer. I hope you understand the concept, and I mean you can now do anything with it with your features. Okay, so this is feature binarizer. Now what is K-Bin-Discretizer, and why we are explaining these both concepts in one video? Because these both concepts are very interlinked. Okay, in feature binarizer you convert your data to Boolean values. In K-Bin-Discretizer you convert your data into numeric values. Now what do we mean by this? The rest of the procedure is exactly same. What do we mean by numeric values? Okay, so let's say you have to convert your age data into 3 categories. Okay, so let's say first category is anyone who is less than 18 would be kid, right? Anyone who is from 18 to 40 will be, let's say, young, and anyone who is greater than 40 will be old. Let's say you want to implement this. Now your features are not going to be binary because you have more than 2 features, right? You have 3 features here. So here you have to implement K-Bin-Discretization. You cannot use feature binarization over here. So let's say we have this data of age, right? And we want to convert this data of age to K-Bin-Discretization. So how can we do that? Simply, very simple. We go back, and we already have our data, and we have imported this pandas data frame PD. Okay, so PD have this magical function. Let's come over here. Let's forget about these warnings. Okay, so PD have this magical function that is called qcut. So qcut actually an implementation of K-Bins-Discretization. Okay, so here I will pass PD, which is pandas data frame dot qcut, and in qcut I have to pass the column, which is age for now, and then I have to pass the number of bins, like how many bins I want to create. Here in example I have created 3 bins. Here let's say I just want to create 4 bins, right? And then I also have to pass the labels of the bins, right? These are the labels. Let's say if anyone is less than 18, what should be the label? Label should be kid, and so on. So I have 4 labels, and let's just run it, and then I'll explain it in a little bit more depth. So here we go. So it says, first of all, here's the summary. It says youngest is the smallest one, right? And then younger, and then young, and then the old is the largest one. So on 0th index, actually let me print age beside it so that we can make a very good comparison. So let me print, and here let's say pandas dataset age. Perfect. So here you can see that. Now, so where age is 44 at 0th index, it says old. Where age is 17 at first index, it says youngest, and so on, right? Okay, so now let's say I want to divide it into three buckets. So I also have to reduce the number of labels, right? Now I have 3 labels. Let me run it, and here you can see that it has been implemented, right? Okay, now you must be saying that this is a textual data. We have learned that it converts data into numeric values, right? So how can we do it? I passed these labels just for your understanding, and if we want to convert it into numeric data, that actually we have to do that in order to implement any machine learning algorithm. So we will pass labels equals to false. So now see what it does. Here we go. It says 2 for the oldest one, it says 0 for the youngest one, and it says 1 for the middle-aged people, right? It actually divides the whole data into 3 parts. We have not applied any threshold on it. You should, I mean, that's sort of your homework. and you can implement it in just core Python. It's not very difficult. So that's how you exactly implement K-bin discretization by using pandas data frame function qcut. Now your homework is to implement it in core Python. It is just one loop and just a few if conditions. That's it. So guys, that's about it. If you have any confusion, just comment below and our team will get back to you as soon as possible. Finally, please visit our website. We have a lot of interesting courses that takes you from data pre-processing up till machine learning, deep learning, CNN, RNN, reinforcement learning, and a lot of cool stuff. And also we have uploaded a computer vision course, brand new computer vision course by Kashif Murtaza. So check it out.